so today we are talking about scientific notation. We just mentioned that this is a way to write very large or very small numbers in a condensed way. That being said, you can actually write every number in scientific notation if you want to. It just doesn't always make sense. So like the number 15, you can write 15 in scientific notation. It makes no sense to because the number 15 is shorter than the condensed version. But if I want to write 15 million, for example. So if I have 15 million, that's a lot of zeros. I don't want to keep writing them over and over and over again. So I'm going to walk you through the steps to convert a number into scientific notation. So here we go. Oh, by the way, does anyone know what this number written this long way is called? Yeah, it's called standard form. So if you're ever asked to convert a number that's already in scientific notation, they'll say convert this number from scientific notation to standard form. This is standard form when it's written out the long way, okay? So to write a number in scientific notation from standard form. Okay, the steps that I'm going to give you work for either big or small numbers. There's going to be one difference that we talk about later on. So first thing we're going to do is we are going to place, well, let me ask you this question. Where's the decimal in this number? Yeah, it's always at the very end. If a decimal isn't already there at the number, it's always all the way at the end. Okay, so this is where the decimal normally is. I'm going to call it the old decimal because I'm going to write a new one. Okay, we're going to place a new decimal after the first non-zero digit as you move, let's spell U right, as you move from left to right. See if my green pen works. Oh, it does. Okay. Can you guys see this? Let me zoom in a little bit. Okay, so if I follow step 1, I'm going to move from left to right across my number, and as soon as I hit a number that's not 0, I want to place a decimal right after it. So in this case, right away I hit a number that's not 0, so I'm going to put my new decimal right after it. So there is my new decimal. Okay, so now in step 2, we're going to drop off all zeros that are not in between other numbers. What I mean by that, and I'll do an example in a minute. In this case, all of these zeros are going to drop off. If I had a number that had a 0 in between the 1 and the 5, I wouldn't drop that 0. So it depends on the number. In this case, all my zeros will be dropped. I'll do an example in a minute where we keep one that's in between other numbers. So if I drop all of those numbers off, I get a new number, in this case 1.5. Does everybody see that? Are you with me?
Can you zoom out a little bit?
Oh, yeah. Thanks. So after step 2, you get some shorter number. That shorter number should always be 1 or larger, but it must be less than 10. So if you have a number here, when you drop off all those other numbers, if that number was 15, I would know that I did step 2 wrong, because that's too big. Okay, so I'll put a big star because this is really important. Your new number should be one or greater and less than 10. So can it be 10? No, it has to be less than 10. 9.999, fine. 10, no. Could it be 1?
Yes.
Yes. 1 or bigger than 1, but less than 10 at the same time. So in our case, our new number is 1.5. So I'm going to write that over here. 1.5. Now I'm going to multiply my new shorter number by 10 to some power. It's always going to be times 10 to some power. Well, how do you know what power it is? I'll talk about that in step 4. But step 3, let's just jot that down. Step 3, multiply your new number by 10 to some power. Does anybody know how to find that power? Oh, good guess, but wrong. Sorry. Taylor, go ahead. It's the number of decimal places, which is not always equal to the number of zeros that you have. Sometimes it is. Sometimes it is. But in this case, it's not going to be. So it's the number of spaces between your old and new decimal place. So if I go back to my original and I count the spaces between them, I've got 1, 2, 3, 4, 5, 6, 7. So in this case, I'm going to multiply 1.5 times 10 to the 7th power. Okay, so let's put that in number 4. So to determine the power, count the number of decimal places between old and new. Oh. So in our case, it was 7. I have to zoom out just a tiny bit to get our number back in. We're going to put a special star after step 4 because something's going to come up. So we just represented a pretty big number using scientific notation. You're done, by the way. This is it. 1.5 times 10 to the 7th. That is the same thing as 15 million. So a condensed way to write 15 million, 1.5 times 10 to the 7th power. However, I've been saying you can write a very large or a very small number using scientific notation. There's going to be one tiny little change if you have a teeny number. So let's try another teeny number. So we'll do another example over here. Say I had 0.0000015. I'm sticking with the 15 just so we can see the difference. All my steps are going to be the same until I hit number 4. So let's start off with number 1. Place a new decimal after the first non-zero digit as you move from left to right. So here's my old decimal. Who can tell me where the new one would be? Alec? Yeah. As I pass from left to right, the first number that's not a 0, ding, 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 there it is. 1's not a 0. I put my new decimal right after it. Step 2, bless you. I'm going to drop off all the zeros that are not in between. So in this case, I'm dropping all these zeros off in the front because they're not sandwiched between two other numbers that are not 0. So my new number in this case, again, happens to be 1.5. So I'll do 1.5 times 10 to the, now because this is a small number, a number that was less than 1 to begin with, we need a negative exponent. So I'm still going to count the spaces in between, 1, 2, 3, 4, 5, 6, but I have to give it a negative exponent. So that will be 1.5 times 10 to the negative 6th power. So let's add this as a little star here after step 4. If your original number is a small, I'm going to be very specific. If your original number has an absolute value less than 1, your exponent will be negative. Let me explain why I said what I just said here. What if I had the number negative 15 million? So it's 15 million is just negative. Would I use a negative exponent there? No, because the absolute value of negative 15 million is what? 15 million, and that's clearly bigger than 1. That's why I have to throw in absolute value, because I could just start with a negative number that happens to be really big. So if I took the absolute value of a number and that number was less than 1, you're always going to have a negative exponent. Here's some other ways that I've heard people try and remember if you have a positive or a negative number as an exponent. If you follow always from old to new, if you start at the old and you go to the left, it'll be positive. If you start at the old and you go to the right, it's going to be negative. You could do it the same way if you always start at the new. If you start the new, but now, so it's kind of confusing because it's like, well, when do what? Am I supposed to start with new, old, which way? So I think it's kind of confusing to do it that way, but if that works for you, that's fine, as long as you find something that works. For me, I just look at the number. Hey, it's a really big number, it's a positive exponent. Hey, it's a really teeny tiny number, little decimal number, it's going to have a negative exponent. So whatever works for you, as long as you got it down, that's fine. Now, I told you I would do another example that had a 0 in between numbers. So let me just go down here and I'll do that. Say we had, and let's make it negative, why not? Let's say we had negative 2, 3, 0, 7. I'll do this. Say I had that number. So it's a really big number, it just happens to be negative. If I want to write this number in scientific notation, well, let's start with step 1. Place a new decimal after the first non-zero digit as you move from left to right. Where would my new decimal go? Alec?
Between the 0 and the 7 on the left side of the
Right here?
Yes, right
Well, be careful though. You want it after the first number that's not a 0 as you go from left to right. Yeah. In between the what? Yeah, it's going to be, as I move from left to right, the first number that's not a 0 is 2, right? So I want my new decimal right after it. So I'll put that in red. So I'm going to have a new decimal right here. Where was the old one? Yeah, it was at the end before, because when it's those big numbers, we usually don't even put a decimal. So now, step 2 says to drop off all the zeros that are not in between the other numbers. This 0 right here, isn't he sandwiched between other numbers? So he's got to stay. He's a placeholder. I can't drop him away. However, I can drop these ones off. So I'm going to drop all of these numbers off, and I'm left with the new number, negative 2.307. Does that fit my requirement of being 1 or bigger and less than 10? Yeah. I mean, yeah, it happens to be a negative number, but we don't really care about that. So I've got 2.307 times 10 to the 9th. Positive or negative?
Positive.
Positive. Perfect. And this just happens to be a negative number. Like the whole number is negative. The exponent's not. The whole number is negative. Does that make sense? Do you see how that 0 stayed? It was important. It had to be part of, because it's holding a place in between two numbers that are not 0. Any questions on how to write numbers in scientific notation?
No.
Let's try. What if I gave you a number like this? What if I gave you, I don't know, 635? And I asked you to write that in scientific notation. Kaylee.
6.35 times 10 to the 7th.
Woo! Did you hear that? She's right, by the way. That's very good. So, if you follow the steps, place a new, first of all, my old decimal's here, right? There's the old one. The new one would come right after the 6. So my new number is 6.35. Does that fit the requirement between 1 and 10?
Yes.
Yeah, so I got 6.35 times 10 to the power of, to the 2nd. This one just had no zeros to drop off. Oh well. But it doesn't really make sense to write the number 635 in scientific notation. You're writing more than you would if you just wrote the number normally. Make sense? Okay. Are you ready for perhaps a trick question? What if I asked you, let's do 4.25 times 10 to the negative 3rd. Say I gave you a number that was in scientific notation, but I asked you to write it back in standard form. How do you do this? Kaylee, tell us.
0.00425.
How'd you do that?
I started at the decimal point and went through the places to the right.
Yeah. Now, converting from scientific back into standard is actually fairly easy because the exponent tells you exactly where to move the decimal. So, if I have the number 4.25, I have to move the decimal negative 3 spaces. Well, is negative 3 to the left or to the right?
Left.
To the left. So I'm going to move it 3 spaces. That's 1 space, 2 spaces, 3 spaces. That's where my decimal is going to end up. And then you just fill in those holes with zeros. So your new number is 0.00425. See how that works? Here's something I always laugh at because I get, when we take a test or a quiz on this, someone is going to turn into me a number that has 2 decimals. What? You never saw a number with 2 decimals, did you? I certainly haven't. So make sure that you clean your number up and you write it nicely. I don't care if you have the 0 out in front here. That really doesn't make any difference to me. But you should only have 1 decimal in your number. Try this one. What if I gave you 5.103 times 10 to the 4th? Everybody please try and write that in standard form. Remember, the exponent tells you where to move the decimal point. Since the exponent is a positive 4, which way do you move your decimal this time? To the right. How many spaces? 4. So, who can tell me my new number? Josie, go ahead.
51,030.
51,030 is correct. I would take 5.103. I'm going to move it 1, 2, 3, 4 spaces. I fill in that hole with a 0 and then write it clean. 51,030. I don't care if you have a decimal on this number because we normally wouldn't write it, so that's not a big deal. How do we feel? Ready for one where I try and stump you? I'll take that as a yes. Yes, Miss Xavier. Can't wait. Well, before I do that, one more thing. Is this number in proper scientific notation, yes or no?
No.
49 times 10 to the negative third.
Over 10.
Right. My number here is too big. Can you fix it? Take a minute and write this number in proper scientific notation. So fix it. So we can't have 49. 49 is too big. What should it have been? 4.9. Now adjust that exponent as you see fit. I'm going to show you how I do this so that I never mess up, because I think we're going to get two different answers here. And obviously we can only have one. We got some answers? Maybe? All right. So here's what me personally, this is what I'm going to do. I'm going to just look at the number 49. And I'm going to write the number 49 in scientific notation all by itself. I'm going to imagine that times 10 to the negative third is not even there. So how would you just write 49? 4.9 times 10 to the first, right? Or just 10. Now, so I just rewrote this as this. Now I still have this times 10 to the negative 3. So now, if I simplify this, notice how these two numbers have the same base. They're both 10. Yeah, I'm going to add those exponents. So what's 1 plus negative 3? Negative 2. So that number written correctly in scientific notation is 4.9 times 10 to the negative 2. This can get tricky. So let me show you another example. Say I had done, I don't know, 0.0075 times 10 to the negative second. Is that proper scientific notation? No. Too small, right? That should be 1 or bigger and less than 10. That's way too small. So again, I'm going to just deal with that for a minute. If I just wrote that number in scientific notation, what would it look like? Just that number right there. 7.5 times 10 to the negative what? To the negative third. Does everyone agree? Is everyone okay with? Hold that thought. Well, do that and then see if you can finish this while I talk to Miss Kemp. Good morning, Miss Sabia. Yeah. Hold on, let me check. Courtney? Yes, I do. Yes. Kind of. Can we wait like 3 minutes? Okay, I'll send it right down. Thanks. Bye. Then why don't you see Mr. Lucas? And like, as soon as I'm done.
Okay.
Yeah, but you'll be right back.
Okay.
Okay. Do we get a number? All right, so this one we said was 7.5 times 10 to the negative third, right? And then times 10 to the negative second. So when I put it all together, it's 7.5 times 10 to the negative fifth. Not bad. Okay, so that's me personally, that's how I handle these. One side note about scientific notation that I've always found weird, all of a sudden we bring back in the X as a time symbol. Isn't that weird? Yeah, instead of, because times you almost never see this anymore, but for whatever reason in scientific notation, it's an X for a time symbol. Is it going to be wrong if you put a dot? No, but for whatever reason, this is the convention for scientific. Okay, here's one I want you to try, and then we will move on to something else. So try this. 50.1 times 10 to the negative third. Oh, thank you. 4.8 times 10 to the negative 1. 0.52 times 10 to the negative third. And 56 times 10 to the negative 2. What I would like you guys to do is please order these from least to greatest. you want a helpful hint, or should I just leave you to it?
It was good.
Okay. So give this a shot. See how we do. If you're stuck, let me know. Sean, I don't think that's gonna help you. Ay, ay, ay. So we want least to greatest. Unfortunately, you can't do that because if it has a negative exponent, that means you're going to take this and move it to the left, right? So it might actually be a smaller number than the other ones that you see. Yep. I did. So the only one that's in proper scientific notation is the second one. So the first, the third, and the last one aren't right. You know what I mean? So you can either change them to be right, or we'll talk about a little helpful hint in a second. I want to see how you guys tackled this. How do we do? Do we have a guess? Yep.
Wait, I don't know what's in the proper scientific notation. Could I just like use the -3 as an estimate?
Yeah. So, here's some options you have. First of all, we notice that we've got some numbers that are not in proper scientific notation, okay? So one thing you could do is write them correctly first. I claim that you actually don't have to do that. You could. I think there's a little bit of an easier way though, particularly for these. What I might do with these, and I'm wondering if anybody did the same thing, I might actually write them in standard form. Write them as normal numbers. You did? Okay. So let's take a look. This first one, 50.1 times 10 to the negative third. If I was to write that in standard form, what does this -3 mean to do with the decimal? 3 spaces to the left. So that'll be the number 0.0501. Correct? Okay. Second one, 4.8 times 10 to the negative 1. What's that look like? If I write it in standard form. 0.48. What's this one?
0.052.
Careful. You got to do 3 decimals to the left, so I'm going to have 0.00052. You see that? And then the last one, 56 times 10 to the negative 2, that becomes 0.56. Good. Now that these are all in standard form, this might be easier for you to order. So which one has to be the smallest in this whole set? Yeah, this one. So this one would be our smallest number. What's the next smallest? Yeah, this one. So there's second. And then out of these two, I want least to greatest. So who's smaller out of 0.48, 0.56? Yeah. I always think of these as money. 48 cents and 56 cents. 48 cents is less than 56 cents. It's easier for me to think about it that way. Yeah. Any questions about this scientific notation stuff? Are you sure? Okay.